Welcome to Maths with EJD. In this video, we're talking about method of undetermined coefficients for non-homogeneous linear systems. In the last video, we had a kind of introduction to non-homogeneous linear systems, where we see that you have the regular homogeneous system, then with a forcing term. So let's revisit that and particularly see how we can use method of undetermined coefficient to deal with that. We've used method of undetermined coefficient for, I think, second order linear ordinary differential equation, but this time around we are using it for systems. So let's see how that works. So an overview, the method of undetermined, let me do it this way. The method of undetermined coefficients is a technique for solving non-homogeneous linear systems of differential equations of the form x prime equals ax plus g of t. Now, in the previous video, we had said it's y prime equals ay plus f of t. Anyhow you want to have it, it's the same pattern. So this is another way of expressing the same thing. We already know that a is a constant, n by n matrix, especially when we need to find the eigenvalue, eigenvector, and all of that normally. So it has to be a square matrix. Then x of t is the vector of unknown functions. So that is x, right? It means you are looking for the x's. So the vector of unknown functions. Okay. And lastly, we have g of t. G of t is a given non-homogeneous. It's the given non-homogeneous term known as the forcing term. Known as the forcing term. Okay. Now, with that said, let's look at steps. I mean, I've said it a couple of times, but I think it's okay to say it again. Steps for solving using undetermined coefficients. Okay. So, of course, first step is to find the homogeneous solution. Find the homogeneous solution. Okay. Here, you solve x prime equals ax. That's the homogeneous part without the forcing term. So solve this to get the general solution. So we know part of ways of solving this is to find eigenvalues and all of that. So to get the general solution of the homogeneous system, you can call that xc of t. That's like the complementary function. Then number two, you guess the particular solution, which can be seen as xp of t in this case. So in this case now, so based on the form of GT. So for undetermined coefficient, the form of GT is really important. Based on the form of GT, so you have to assume a trial function assume a trial function with undetermined coefficient. That's where the name comes from. So you have undetermined coefficients that you want to determine in the process, right? So that's like the second step. Then after you've looked for the homogeneous solution, then we go for the third step. In the third step, we substitute into the differential equation, to the differential equation. Okay. So substitute into the differential equation and then determine and determine the coefficients. So those undetermined coefficients, you now determine them here. Determine the coefficients by solving a system of equations. And step 4, you obtain the general solution. Obtain the general solution. And as usual, for differential equations, we already know that that's especially for non-homogeneous equations. So we obtain this by combining. So we combine xc of t plus we combine xc of t and xp of t to get the complete solution the complete solution y of t. So in essence, you're saying that you're looking for y of t, which is equal to yc of t plus yp of t. We've done this kind a lot already. So that's how we go. So can we switch gears now and move on to do some solutions? Okay, so imagine this example. Solve the system. Solve the system. X1 prime equals 3x1 plus 4x2 plus e raised power t. Okay, so g1 of t is e raised power t then x2 prime is 2x1 plus x2 plus 2e raised power t. So we need to solve this system now. So as usual, step one, we solve the homogeneous system. Solve the homogeneous system. That means we leave out the forcing terms. So we are looking for okay. The system in matrix form, that's the non-homogeneous system in matrix form, is x prime equals ax, and then we have a to be 3, 4, 2, 1. Okay, so we have to find the eigenvalues. Find the eigenvalues. We have found this before by solving the determinant of a minus lambda I equals 0. So that means the determinant of a minus lambda I now simply means we have the determinant of a, which is 3, 4, 2, 1 minus lambda 0, 0 lambda equals 0, or better still 0, 0. Okay, so that means that we have the determinant of 3 minus lambda like that. Then 4 minus 0, 4. 2 minus 0 is 2. 1 minus lambda is 1 minus lambda, and that is 0. So determinant of this simply means we multiply this, that's 3 minus lambda into 1 minus lambda minus 2 times 4, that is equal to 0 now. So that we now have 3 times 1 is 3, 3 times lambda is 3 lambda minus lambda times 1 minus lambda plus lambda squared minus 8 equals 0. So that we have lambda squared minus 4 lambda. 3 minus 8 is minus 5, yeah? And this is equal to 0. Okay. So in this case now, we can find, so of course we have this now. So here we now have, we need lambda, which is plus or minus, which is minus b plus or minus square root of b squared minus 4ac all over 2a. So if we have lambda squared minus 4 lambda minus 5, right, equals 0, that simply means we have a, the a we need up there is the coefficient of lambda squared, which is 1 here. Then b is the coefficient of lambda. A is the coefficient of lambda squared, B is the coefficient of lambda, which is minus 4, and C is the constant, which is minus 5. So in this case, we can have lambda to be minus 4 plus or minus square root of B squared, which is minus 4 squared, minus 4 into 1 into minus 5, like this. So all over 2 times 1. So we have lambda to be 4 plus or minus square root of 16 minus, 16 plus 20, right? Right, yeah. So all over 2. So this is lambda equals 4 plus or minus root 36 all over 2. Root 36 is, 36 is a perfect square. So we have 4 plus or minus 6 all over 2. So we have lambda 1 equals 4 plus 6 divided by 2. And lambda 2 equals 4 minus 6 all over 2. So that lambda 1 is equal to 4 plus 5, 4 plus 6, 10 divided by 2, 5. And lambda 2 is 4 minus 6 minus 2 divided by 2, that's minus 1. So we have our lambdas that way. So with that done, we can go ahead and find the eigenvectors. Okay, so to find the eigenvectors, okay, solve for v in a minus lambda I v. So we are looking for v. So in this arrangement, we are looking for v. So we take the lambdas one after the other. So we say for lambda 1, which is equal to 5 now. So we have a minus 5i v equals 0. So that means we have, say a, which is a is 3421 minus 5005. Okay, then we have v1, v2, that's the v we are looking for, and all of that is equal to 0, 0. So that means you're looking for 3 minus 5 is minus 2, 4. 4 minus 0 is 4. 2 minus 0 is 2. 1 minus 5 is minus 4. And so v1, v2, that is equal to 0, 0. So we're already seeing patterns that are regular. So v1, v2, again, v1, v2. So for the first one, we have minus 2, 4. That's minus 2, 4 here. And for this, we have 2 minus 4. 2 minus 4. So all this is equal to 0, 0. So that's minus 2v1 plus 4v2 equals 0, or 2v1 minus 4v2 is equal to 0. So anyone you pick, the relationships are basically the same. So anyone you pick, so if you pick the first one, you have minus 2v1 plus 4v2 equals 0. So that's simply 4v2 equals 2v1. And then that means v2 is equal to 1 over 2 v1, basically. All right. So that goes. If you also use this, if you also use this other one, it's the same thing. We have 2v1 minus 4v2 equals 0. So that simply means 2v1 is equal to 4v2. Better still, v1 is equal to 2v2. Okay, so in all, for that, we have v to be equal to, so whatever V2 is V1 is double of it. So it means that if V2 is 1, V1 is 2, basically. So the eigenspace, we can say, so the eigenspace there, the eigenspace for that is, you can write it like this: 5 for the lambda, 5 for the eigenvalue, and then 2, 1 for the eigenvector. Okay, because V1 is double of V2. So we have that, but that's not all, right? We still have the other lambda, which is -1. Okay, so we say for lambda 2 equals -1, for lambda 2 equals -1. Well, we now have a minus 5, a minus, so that'll be a plus lambda I now, a plus lambda I, because this is minus, right? So, and yeah, so a plus lambda I. So for a plus lambda I, v equals 0. So we are looking for v. So again, we have a, which is our a again is 3, 4, 2, 1 plus lambda 0, 0, lambda. Okay, v1, v2 equals 0, 0. And then this is 3 plus lambda. So we have 3 plus lambda, 4 plus 0, 2 plus 0, 1 plus lambda. This v1, v2. Oh, why am I still having lambda? Sorry. It should be 1, right? It should be 1. Since, sorry. Yeah, this place should be okay. Yeah, this should be 1, just 1. So this should be a plus lambda v. So this is 1, 1, basically. So we have 3. 3 plus 1 is 4. 4 plus 0 is 4. 2 plus 0 is 2. 1 plus 1 is 2. Yeah. So this is what we should actually have. And this is v1, v2 equals 0, 0. So what this simply means is that anyhow you look at it, you have v1, v2, v1, v2. So this is 4, 4 here. This is 2, 2 here. All of this is equal to 0 each. So you have 4v1 plus 4v2 is equal to 0, or 2v1 plus 2v2, 2v2 is equal to 0. Anyone you take is fine. So let's just take any random one, because basically they both mean v1 plus v2 is 0. This one also means v1 plus v2 is 0. So anyone you take, you're good to go. So v1 plus v2 equals 0 simply tells you that v2 is equal to 1 minus v1. Okay, so you can shift the minus anyhow you like. So v in that case will simply be whatever. So fix v1. If v1 is 1, then v2 is simply -1. That's what that simply means. Okay, so again, the eigenspace the eigenspace is, you have -1 as lambda, and you have 1 minus 1 as eigenvalue. Okay, so we have this. Now that you have found all of these things, so what we have been doing so far is just to solve the homogeneous part. So we can now write out the solution, right? So you can say, thus the homogeneous solution is xc of t, which is equal to, if you remember, we got the, okay, well, I'll just write it out generally. So this is c1 e raised to power lambda 1 t, okay, uh multiplied by the first eigenvector plus c2 e raised power e raised power lambda 2t multiplied by the second vector, the second eigenvector, which is v2. So this is like what it should look like here. So if we fix up all the values we know, that's going to be xc of t equals c1 e raised to power 5t v1, which is 2, 1, plus c2 e raised to power minus t, and v2, which is for my v2, we have 1 minus 1. It could also be minus 1, 1, anyhow you like it. So this is 1 minus 1. So this is the homogeneous solution here. And everything we've been doing has just been step 1, right? So step 2, so for step 2, we now have to guess. We're talking about undetermined coefficients. Guess the particular solution. Guess the particular solution based on the forcing function, right? On the forcing terms. So if you remember the original formula, the original expression, we know that gt is equal to e raised power t to e raised power t. If you remember from the very beginning, when we started to solve this problem, the original question we had, we see it's et and 2e raised power t. So you want to refer to that. Okay, so now because we are looking for particular solution, so we go for that. So gt is that. So since gt is all that is an exponential, since it is exponential, okay, we assume, we assume first, and we assume that xp of t is simply a b e raised power t. Okay, because for exponential function, if you keep differentiating e raised power t, it keeps giving you the same thing forever and ever. Okay, so we keep having that same thing. So, and now that this is like this now, so this is our guess. Basically, this is our guess because both of them are exponential in nature. So the next thing we want to do in step 3, we want to solve for coefficients. So this AB now are the undetermined coefficients. So these are the undetermined coefficients where the method derives its names from undetermined coefficients. Okay. So we want those AB now. All right. So solve for coefficients A and B, as you can see there. All right. So what do? From the original expression, right? We have X prime. We have a first order thing. All right. So it means you have to differentiate that XP once. So if you have XP of t to be AB e raised power t, then it means XP prime of t is equal to, of course, AB e raised power t. Nothing changes, right? It remains exactly the same thing. So the next thing I want to do is to substitute into the system. Okay, so uh substituting into the system. So if you remember the original system, it's important to remember the original system is x1. So we can now say xp, can we say xp1? xp1 prime, okay, equals 3xp1 plus 4xp2, all right, plus e raised power t that was there originally, right? Then we have xp2 equals 2xp1 plus xp2 plus 2e raised power t, so that we can now substitute all of these things here. Okay, so basically now we are then going to have, so on the, okay, substitute into the system. So this is the original system, right? Original system. So if you substitute now, instead of or this is in summary, right? I'm trying to make it as tidy as possible. So it's in summary, this is like xp of t, right? This is like xp equals 3. Okay, I mean, let's just go ahead and put that. It's like I don't want to confuse things up too much. So basically, right? Okay, I mean, I think it's fine still. XP prime, right, is equal to the whole system 3, 4, 2, 1. Okay, 3, 4, 2, 1. What was there before? We had our 3, 4, 2, 1, right? And we had our XP exactly. So this is XP1, XP2, yes. Plus e raised power t, 2e raised power t. Yeah, this is the original thing. So we substitute into this now. So this xp prime, as you remember, xp prime is this expression here. So that is simply, so for this xp prime now, we just have ab e raised power t. So this is ab e raised power t for this side equals 3, 4, 2, 1 into, so instead of this now, we now have ab. Okay, we have AB e raised power t because this is like our x. This is like our x, which is equal to AB e raised power t again. So that replaces that. Plus what was there originally? Okay, plus the ET, 2ET that was there originally. So we have substituted like this now. Is so from here we can begin to tidy things up. So it's glaring that e raised power t is common everywhere. At least we can rewrite it as AB e raised power t is here is equal to 3, 4 to 1, 3, 4, 2, 1, okay, into AB e raised power t plus 1, 2 e raised power t. So we can cancel out all the e raised power t, divide through by e raised power t, and all of those will just go away, right? So we're now left with AB equals 3, 4, 2, 1 AB, okay, plus 1, 2, because all the ETs are gone. So we are looking for, basically, we are looking for AB. So this is AB equals, and you know how we multiply, right? This is two rows. So we have AB twice, and this is 3, 4, and this is 2, 1 here, plus 1, 2 right here. So this is AB equals 3A plus 4B, and this is 2A plus B, then plus 1, 2. So this is still AB equals 3A plus 4B plus this one here. All right. Then 2A plus B plus 2. So we have this tidied up. So we have to begin to solve, right? So for the first one, we have, so for this, we have A is equal to 3A plus 4B plus 1. So we can tidy this better. So 0 is equal to 3A minus A plus 4B plus 1, and that is like, so we have 0 equals 2A plus 4B plus 1. Okay, so this can actually be minus 1 equals 2A plus 4B. Okay, so finally we have 2A plus 4B equals minus 1. So we have that tidied. Then we can go for the next one. B equals 2A plus B plus 2. Okay, we have B equals 2A plus B plus 2. That's from this expression now. Okay, so we have to also tidy that up. So this is 0 equals 2A plus B minus B plus 2. So this simply cancels out. Interestingly, we have 0 equals 2A plus 2. That means minus 2 is equal to 2A. That simply gives us that A is equal to minus 2 over 2. So interestingly, A is equal to minus 1. So we don't have to worry solving the simultaneous equation again. So A is minus 1. So we can go back here. So we can say from 2A plus 4B equals minus 1. A is already minus 1. So we have 2 into minus 1 plus 4B equals minus 1. So we have minus 2 plus 4B equals minus 2. So 4B equals minus 1, right? Equals minus 1. So 4B is equal to minus 1 plus 2. So that 4B is equal to 1. And B is equal to 1 over 4. Okay. You can say therefore AB is equal to uh AB is equal to minus 1, 1 over 4. Okay. E raised power t now. That's where we started from. So we go back to, this is like our XP, right? So we can say You remember, right? So, uh, first of all, AB is equal to minus 1, 1 over 4. That's what we have got here now. So we can go back to where we're coming from. So we can say, therefore, XP of t, which was actually taken to be AB e raised power t, can then be said to be XP of t equals A is minus 1, B is 1 over 4, and multiplied by e raised power t. So this is our XP of t. So with this in place now, then we can have the general solution finally. That's step 4, I think. Step 4, we can have the general solution. General solution. Okay. So we know general solution is x of t, which is xc of t plus xp of t. Okay. So we can put both together. So x of t is equal to, what is xc of t again? If you still remember, it was a long time ago. What's that now? So xp of t, yeah, this is it here. C1 e raised power 5 to 2, 1. C e raised power minus t, 1 minus 1. Then plus xp now, okay? So just write that, uh, put that up, and we are good to go. So x of t now finally is C1 e raised power 5t into 2, 1 plus C2 e raised power minus t into 1 minus 1, okay, plus minus 1, 1 over 4 multiplied by et. Okay, so this is our general solution. So this completes the process, right? So we see that in conclusion, the method of undetermined coefficients is effective for solving non-homogeneous systems when g of t is a polynomial or exponential, like in this case, or trigonometric function, whether it's sine or cos. So the key steps are solve the homogeneous system, make an educated guess for the particular solution, solve for undetermined coefficients like we solve for A and B, then combine solutions for the general expression. So, but then, what I think I really need to take notes of this conclusion. So it's really important. That's going to lead us to our next video. So interestingly, this approach is limited. This approach is limited to specific, is limited to specific forcing term g of t. All right. So for more general cases, variation of parameters, of parameters is needed. Okay, so it means that once the forcing function g of t is not exponential, it's not polynomial, and it's not trigonometric like sine or cos, then you won't be able to use undetermined coefficient. So that makes variation of parameters a more general method to use. Okay, so that's how this goes. Okay, before we round things off, can we talk about some practice questions? Just try your hands on the following practice. So let me see. Hey, um, number one, the system, solve the system y1 prime, y2 prime equals 3y1 plus 4y2, okay, plus cos t, then here 2y1 plus x2, plus y2 rather, 2y1 plus y2 plus sine t. Okay, so the forcing term now, in this case, they are sine and cos, so you can actually deal with them together. Okay, no, question two, you also want to solve. So we can also represent it this way: x prime equals 2 minus 3, 1, 0, x plus e raised power t, e raised power t. That goes. Then we can also have number 3, where we solve, let me see, where we solve x prime equals 0, 1 minus 2, 3, x plus t squared t, like this. Then number 4, what if, okay, I think we have this type already. Let me go for something else. So number 4, you have to solve x prime equals 5, 2 minus 1, 3 x plus t e raised to power t, then 2t e raised to power t. Okay, that. Then lastly, number 5, consider the system. Consider the system x prime equals ax plus g of t, the forcing function that is, and a is equal to 0, 1, minus 5, minus 2, and g of t is equal to e raised to power t, e raised to power t. Okay, solve for x. Okay, that's what we need to do there. All right, so with this, we come to the end of this function, of this particular video. And let me see your, feel free to let me have your answers in the comment section, either on YouTube or on Facebook. Okay, YouTube or Facebook. And of course, in the comment section, let me also know how helpful these videos are for you. And let me know if there's a topic you'd like me to teach or a problem you'd like me to solve. If you have not subscribed already, you'll be missing a lot, because in the next video, I'll be talking about variational parameters, which is a more general method for solving non-homogeneous linear systems. So you want to subscribe, and if you have subscribed already, so everybody, don't forget to hit the notification bell so you can get an alert. You can get alerted each time a new video is released on this channel. And don't forget to like and share so that more people can have access to the great content going on here. Until I come your way again, keep doing maths right. Bye.